Welcome back, everyone. Next up, we have Odyssey Semiconductor Technologies, Inc. It trades on the OTCQB under the symbol ODII and has developed a proprietary technology that is designed to allow for GaN to replace SiC as the emerging high voltage power switching semiconductor material. Based in Ithaca, New York, the company owns and operates a 10,000 square foot semiconductor wafer manufacturing facility, complete with a mix of Class 1,000 and Class 10,000 clean space, as well as tools for advanced semiconductor development and production. Odyssey Semiconductor also offers a world-class semiconductor device development and foundry service. Please welcome its CEO, Mark Davidson. Welcome, Mark.
Thank you so much, Anna. And thanks to everybody for choosing to spend some time with us here this afternoon or morning, depending on where you are.
Right on. Take it away.
All right. We'll go standard safe harbor statement. So let me give everybody a quick introduction into Odyssey Semiconductor, ODII. First of all, we're a semiconductor company, and there's a lot going on in semiconductors right now. The federal government passing the Chips and Sciences Act. We know how important semiconductors are. We're in a space called analog and mixed signal. And our job in analog and mixed signal is to turn real world into digital, turn the real world into something that can be used by electronics. So we are in an area called power conversion, where we're going to convert a different type of electricity into the type of electricity that can be used by electronics, electric vehicles, for example, et cetera. That's the space that we're in. And what makes Odyssey Semiconductor unique and what we're very excited about is we are a company that has successfully built this thing called a vertical GaN. GaN is gallium nitride power device, which means 1200 volts. And what you're going to learn through this presentation is there's a huge gap in the market of providing high efficiency, high performance power conversion devices at this voltage level. There is competition from another material called silicon carbide, but we're in rarefied air, proving to the world that we can build these high voltage transistors. And I'll explain to you why that's important. To give you an idea why this technology is important, an order of magnitude performance improvement over the competitive solution, silicon carbide. Order of magnitude, not percentage, not nominal, order of magnitude. What that means is better yield, better performance, better economics, more smooth supply chains. These are the things that we hear about all the time that's been challenging electronics and semiconductor industry, especially over the last few years. The market we're pursuing, growing to $5 billion, 40% CAGR. It's large and it's growing fast at very, very healthy margins. And I'll talk about margins in a minute. And there's, the megatrends, which I'll explain. Megatrends are driving the need for our solution: high voltage, vertical GaN, high voltage, high performance, et cetera. So very quickly, that's who we are. That's Odyssey Semiconductor. And timing being what it is, very, very exciting and important time. So in September of last year, we announced that we successfully built this thing called a 1200 volt vertical GaN FET. In January, we announced that we had completed wafer fabrication. So as Anna said, we have our own wafer fab right down the hall from where I'm sitting right now. And we completed wafer fabrication of Gen 1 engineering samples. We have a long list of customers that have expressed interest in getting these samples. And we will start to sample in March, in 3 or 4 weeks. That's how close we are to getting these into, from the lab into customers' hands. So as I said, very, very exciting time. And the purpose of this slide is to really visualize. Odyssey was formed in 2019, and a great deal of effort was put into all the materials and process R&D, intellectual property generation and protection, of course, to figure out how to build these things called vertical GaN FETs. And now that we've done that, we move into this kind of product development with and for customers. So a very exciting time as our company has hit this milestone where we're really outward looking now. We have the technology and the products that customers want to test. So let me summarize kind of, the recent advancements and milestones here just for a second. So there's 2 major product lines, 650 volt and 1200 volt. The 1200 volt is the product line that we're most excited about because very little competition there. And that product sample fabrication is complete, on schedule. We said we were going to do it in Q4 of 2022. We completed it. The parts are out for what's called assembly right now, where they get packaged so they can be mounted onto circuit boards. And that's why we'll be shipping samples. We'll do some internal testing here through this month and then be ready to sample customers. Our objective is by Q2 to use this product sampling with a handful of customers and turn that into some product development agreements where we're getting customer commitment to prove that these are not just interesting novel devices, but they're actually devices that have customers and have an important fit in the market. On the business front, as Anna said, so we are a product company with manufacturing, and one of the things that we try to do in order to just reduce our net burn per month is use our manufacturing facility to generate some revenue. So it's a business that is really just starting to ramp up. We got a very strong pipeline of opportunity for what we call foundry services. We did $321,000 in 2022. This is the year we say we'll grow 50% this year versus last year, and that's just the beginning. We see this coming in as a multi-million-dollar per year business. Again, it gets to use some of the capacity we have and make sure that we're exercising equipment, but more importantly, we're generating some cash. At the end of the year, we did secure additional funding. So we're a very small, lean company. So we were able to secure $2.35 million. We will be doing a capital raise first half of 2023, Q2-ish. But we were able to secure some funding to allow us to keep operating and get these products into customers' hands. And we're also spending quite a bit of time working with some partners to make sure that we're in line to get some of the funding coming out of the CHIPS Act. Nothing to announce on that yet, but we're really kind of focused on efficient ways to generate even more manufacturing capacity as we are going to be pursuing a very, very large market. So, a good summary of where we are as a company right now, getting products out of the lab into customers' hands. That's very exciting. Yesterday we had our earnings call, and I shared a story where we were on a call with a customer. The customer sent us very detailed specs going after a large opportunity in electric vehicles. Everything that they were asking for is well within the envelope of our technology. We spent a lot of time deciphering it. So the fact that customers are already sharing specs with us, it's very exciting. I think what it proves is that what we're building here truly is needed in the marketplace. I think the other anecdote I'll tell is I've been in power semiconductors for over 20 years. It's the first time where I'm actually seeing customers reading my press releases and then reaching out to us asking for samples. Normally press releases aren't targeting customers, but the fact that customers are picking up these press releases and requesting samples, I have a longer backlist of customers for these samples than I can support early on. So we're being very, very thorough in which customers we're going to be sampling right out of the gates. But very excited to prove that the customers are there. So our story that we talk about really is one just focused on execution. Okay, so that was kind of a quick. What I'd like to do here now is talk about the overall opportunity and why Odyssey is here and why the market opportunity is so large. So first thing we'll talk about, these megatrends, a combination of sustainability, electrification, and what we learned through COVID is availability and supply chain, and then of course affordability. You need to have all four of those things for technology to take off to extremely high levels. And we are uniquely positioned to deliver solutions that are power efficient, solutions that work at voltages where energy efficiency is high, and doing it with using the material benefits of gallium nitride to make availability, and of course the affordability. There's only so much people are going to pay for an electric vehicle, and obviously that's the challenge the EV markets have, each EV customers have right now in making sure that they make electric vehicles economical. Here's a summary from Yole Development is a market research firm, have put very, very detailed reports together for different technologies, silicon, gallium nitride, silicon carbide. And you'll notice this is specifically around silicon carbide because there is no market yet for vertical GaN. We are the leaders, we are the first. So, as we talk to our customers, it validates our opportunity is to be a much better solution than what silicon carbide is delivering. So that's why we're looking at the silicon carbide market. And as you can see, growing to over $5 billion, growing 40% CAGR. So this is a large and fast growing market. And we focus on the high end of the market, and we focus on the high voltage part. Less competition. It's very difficult to make a high voltage, highly efficient power transistor. And you can see here some of the markets we're focused on is electric vehicles, solar and renewable energy in general, and industrial motors. It turns out that in the US, almost half the energy consumed in the US is spinning a motor, a blower, or a pump. So focusing on that area, generating greater efficiency, reducing the energy consumption is very important. And our vertical GaN solutions are a very important answer. I kind of talked about this already. High voltage conserves energy. Our customers want to work at higher voltages. For example, electric vehicles, to get greater range out of an electric vehicle, moving from 400 volt batteries to 800 volt batteries. 800 volt, that's higher voltage. Higher voltage means the power conversion challenge is harder. Again, that's where we come through. So I position us against silicon carbide. And what we want to show here is our vertical GaN relative to silicon carbide. We're going to give higher power density, so more power packed into a smaller area, better efficiency, higher energy savings, which is going to dictate energy costs, or an electric vehicle, longer ranges, and higher reliability. There's really no negative of GaN versus silicon carbide, except for the fact that we're early. We are bringing brand new technology out. Silicon carbide is ahead of us, but not that far ahead of us, and they're struggling to really deliver on everything that the market needs. Specifically, and again, this is from Yole Development, that market research firm I talked about earlier. Silicon carbide's biggest issue is they're 2.5 times the affordable price to go big in electric vehicles. They're finding ways to kind of close the gap a little, but at the end of the day, this is order of magnitude economics are off. So it's not, hey, we need to negotiate a 10% price increase or price decrease. There's significant, and it's due to the material, and it's due to the inefficiencies of building a power transistor on silicon carbide. So I commend the silicon carbide companies. They are finding ways to generate some traction, but the fact is that the material advantages that we bring with vertical GaN far outweigh what silicon carbide brings. Great example. So we fabricate our devices on a wafer, and our wafer is a gallium nitride wafer, and we're comparing this to a silicon carbide wafer. So silicon carbide 6-inch, we're 4-inch. And as you can see, because of the material properties of gallium nitride, I could put 10 of my product. So on this wafer are thousands of our product, in this case, 2,128 of our product, we call them die, versus 522. So a 4-inch wafer, where I was going was, so 10 of my product fitting inside one silicon carbide for the same power level, right? So that's significant opportunity for better yield, better throughput, lower cost, etc. So this is a great, I think, visual of why the economics favor vertical GaN. There are companies that are out doing lateral GaN. Lateral GaN doesn't have the same. Lateral GaN is a very different structure. It's built on a different substrate. It doesn't take advantage of all the gallium nitride material benefits that we do when we do a vertical conduction device. So economics are there. But as I've said earlier, it's more than just economics. Performance has to be there. So what we're looking at here is a silicon carbide versus a gallium nitride circuit. And what you can see is higher efficiency for the same output power, 40% smaller solution. So that's, power density is what we're talking about there. So, here we are. And again, imagine an electric vehicle. Weight matters, size matters. All these things matter towards improving the range of an electric vehicle. Smaller, lighter, faster, that's the way to go. So our vertical gallium nitride hits the performance, reliability, and of course the economics to be the leading solution. And Odyssey, we are uniquely positioned. I've used that term a couple of times. Number one, the expertise that we have across technology, marketing, manufacturing, we have it all in-house. We have people that Matter of fact, our power supply applications lab in there with the guys today, looking at the work they're doing to make sure that we have all the right reference circuits so people can take advantage of the products when we sample them. So we've really been focusing on, making sure that we're excellent at all the areas of expertise to make sure that adopting and utilizing our products will be easy. Protected IP. We have quite a few patents. Because we have our own control of manufacturing, and really the intellectual property here is the process and manufacturing of the device. So we have patents, but we also have a lot of trade secret stuff that we'll never put in the public domain. So we feel very good about the amount of IP that we've created and the way we protect it. And just to be clear, there is a bifurcation. There's a 650-ish volt product line and 1200. So we will be pursuing both, but the 1200 volt is really the special area for us. As we talked about, and Anna mentioned it in the introduction, I'm sitting in our facility right now that has our wafer fab, so 10,000 square foot facility. Out of this facility with moderate capital investment, we can generate 10 to 20 million of annual revenue from this facility, which is, that's a good start. We're talking, especially as we think about our CHIPS Act efforts, we are talking with some partners about a very large scale, much larger wafer fabrication facility where we can go, 10 or 20 times this size in revenue to have the capacity for that. So really thinking a couple steps ahead. But as we look at it right now, we control supply. We innovate faster than competition because we can go innovate in the very facility where we will be building product for revenue. Customer engagement. This is an area that I've been spending a lot of time. I mentioned to you one of the calls we had with a customer yesterday. I'm talking to customers every week. The interest is there. So, we're being selective. Like if we try to overdo it here, because we are a small little team, I don't want to overwhelm us or overpromise and underdeliver. So initially we're talking to just a few customers, and we're really looking for customers that are, what we'll call collaboration partners with us, teacher customers that are interested in seeing early product, giving feedback, sharing feedback, committing to a timeline, et cetera, and also committing to that as we work with them, their intention is to help us build the exact right product that they would then use in high volume production. So very selective there. As I said, long backlog of customers. And we're fortunate that we get to select which are the right customers for us to partner with and go to market with. So kind of in summary, going after a large market driven by these mega trends, vertical GaN developed by Odyssey Semiconductor offers the performance and economics needed for continuous high margin growth. And, we're positioning ourselves to capture significant market share. Real quick, for those learning a little bit more about the history and of our fundraising, et cetera, obviously OTCQB, ODII is the ticker. We have strong inside management ownership. You can see our different rounds of financing. And what's important, obviously, we're not on an exchange right now. We do have an S1 file. We've done quite a bit of work in preparing. So at this point now, I guess I would say it as we're waiting for the right market conditions for us to go do our uplist and capital raise. It's going to get us to revenue, product revenue. I don't want to confuse the revenue that we've had coming from foundry. We are a product company, and we're looking to do a capital raise that's going to get us to product revenue. So at that point, I'm going to go to slide 20. It's my contact info. Jeff Christensen handles investor relations for us. If there's any additional information you'd like, please reach out to us. At this point, I'm going to hand it back to Anna for Q&A.
Great job, Mark. Okay, let's jump into some questions from Ronnie Svedbeck. How much does having your own fab speed your production development process?
Yeah, it's great. I can't quantify. I mean, it's enormous. Other places I've worked where we haven't had our own fab, or even when we had large company fabs, your experiment runs are scheduled, and maybe they're once a month. And if you're working with an outside fab, maybe they're very expensive. So the fact that we can have a meeting, the guys can kind of come up with a concept or an experiment and walk right down the road or right down the hallway and run that experiment. Maybe we get feedback today, maybe we get it over the next few days. So I would tell you that it's immeasurable. It's that large. We're not bound by any type of design rules. We will develop the design rules once we invent the product. Yeah, it's immeasurable. That's how large it is.
Dwayne Harris wants to know, where are your chips made?
Yeah, so we buy wafers from suppliers. And we have a couple different substrate suppliers that we're working with. And then we do the fabrication right here in our facility on the wafer side. And then our parts, a lot of these parts will be packaged. And in packaging, right now we're using a US-based packaging house. We'll probably go to Asia, probably somewhere, preferably not China, most likely not China, but other countries. Malaysia's well established, Singapore, Vietnam, et cetera, to do the back end. It's called assembly and test.
Ira Massey wants you to talk a little bit more about your GaN power device. Can you discuss the applications, consumer products, industrial products, and what is it used for? Yeah,
great. Not consumer. So we're really talking about industrial and automotive. So for example, electric vehicle is a great example, I think. In electric vehicle, let's talk about the traction inverter. It's a very challenging application, but one that needs vertical GaN. So in an electric vehicle, you have this thing called a traction inverter. It could be mounted at the wheel, it could be mounted under the car, and then using a drivetrain. And we're sending electricity to it, and that's what makes the wheel spin. So we use the battery voltages are higher. That's why we're high voltage. And what we're doing is we're converting the DC voltage from a battery into AC. Alternating current is what makes the wheel, is how you make a motor spin. So that's an example of all that power and energy runs through our devices. So you want to run at high voltage. It gives you the architecture for higher efficiency. And you want to make sure that the conversion from DC to AC is as efficient as possible. Any power that you lose directly, it's heat, which is bad. And it means that you're losing power that could otherwise go towards extending the range. So we're really talking about converting electricity from one mode to another. But industrial and automotive, our intention is not to be in the consumer markets.
Philip Black wants to know about your Q4 filed on the OTC markets. Has that been posted yet, or when can they expect it?
Yeah, so we have. So we did an earnings call yesterday. Press release went out yesterday as well. Our Q4 and annual is in audit right now, so we'll have the 10K, filed. I would say by the end of March, definitely. I sooner than that, but well within a reasonable time, and definitely on time.
Ross Hughes asks, when you say use your manufacturing facility to generate revenue, is this for other companies to use? Are there any technology risks there?
Yeah, great. I love these questions. So we're not going to use our facility to manufacture any GaN transistor for anybody. So we use our facility. So, one customer is building something called a micro LED. Another company is looking to build a new type of gas sensor. Okay, so all of these technologies take advantage of our capability, which is, we're going after the innovator who's trying to take a new concept and figure out how to manufacture. We're not a high volume, kind of 1,000 wafer manufacturing facility. We are that kind of innovation to validation facility. So we work with all these different types of materials, different type of process flows, but we will not be building any type of gallium nitride transistor or silicon carbide transistor for a company. That way we don't have to worry about any type of pollution of intellectual property.
Thank you for that. So Clyde Francis says the government is spending a great deal of money on factories to build chips in the US. So are there any grants you can apply for?
Yeah, actually our company started by getting an ARPA-E grant back in 2019, actually 2018. So we have, we're constantly looking at kind of smaller grants. We're working with a couple different partners on that as well. CHIPS and Science Act is clearly, the one I think President Biden even talked about it last night at the State of the Union. Semiconductors, I've been in this industry for, like I said, 20 years. I've known for a long time, many of us have, how critical semiconductors are. And I appreciate that the government's finally recognizing that. I guess they recognized it back in the 80s, and now they recognize it again. So yeah, we do spend quite a bit of time looking at grants, which ones are the right ones for us, applying to make sure that we're taking advantage of some non-dilutive money to help us execute.
Sandy Phillips asks, who are you currently selling to? And can you discuss reorders or repeated business?
Yeah, so right now, the only area where we're selling today is in our foundry business. And it's we do have some repeat business. I can't disclose customer names, but you probably wouldn't have heard of them anyway. They tend to be startups, young new companies that have a new concept that need to figure out how to take that concept and learn how to manufacture it and start to get it commercialized. On the product side, that we'll start to have buying customers in 2024. And then, that business we will be building a repeat. If a customer's going to go build, 10,000 or 100,000 industrial motors, they will be putting our chips in every one of those industrial motors. So there will be recurring and repeat business.
And Chris Lowe wants you to talk about your competition and how are your 1200 GaNs doing it better?
Yeah, so there's two technologies, silicon carbide, and Wolfspeed is a company. I have a ton of respect for Wolfspeed. I know a lot of the folks, they're ex-TI people I worked with. Very impressed by what they're doing with silicon carbide. But as I showed in the slides, silicon carbide has material disadvantages relative to gallium nitride. So we're using those material advantages to deliver something that they just, physics won't allow them to do. The other technology that we compete with is something called a lateral or horizontal GaN transistor. And this is where GaN is built on, so conduction happens laterally or horizontally. Power is not designed to be a horizontal conduction technology. It's designed to be vertical. And what the competitors there do is they're using a silicon substrate to do 2D gallium nitride, and it's limited on performance. It can't go high voltage. If they want to go higher voltage, they need to make the die bigger, which makes it, yield becomes a problem, supply chain becomes a problem, and of course, cost becomes a problem. So by building a vertical GaN device, is why what I say is we take the performance that gallium nitride delivers at the voltages that's only silicon carbide can hit right now, and that's how we kind of create this really nice carved out space for us. There is another vertical GaN company, and we see them in the news. I don't know where they are. They're a private company. I don't know where they are, but I haven't seen any real product traction from them yet.
Perfect. Thank you. Nick Bird asks, what capacity can your current facilities handle? Number of units over how much time?
Yeah. So 100 wafers per month is kind of, this is a simple math I do. 100 wafers per month. We'll get somewhere between 1,000 and 2,000 of our die per wafer. Okay. Because we start with this 4-inch wafer and then put multiple on. But if I just say 100 die per wafer, 100 wafers per month, 1,000 die per wafer, and let's say an average selling price of $10, so it's $1 million a month. And then depending on mix, you were talking, that's why I give the estimate of 10 to 20 million just on that basic math.
Diana Jimenez asks, is there any study on how much more efficient your chips will be in EVs versus what's currently being used?
Yeah, I get that question a lot. Once we set an actual, product spec down, we can work with our customers to do that math. The reason why it's hard and the reason why I hesitate a little bit, it's going to come down to exactly how we define the product. If I define the product to be completely maxed out on efficiency, it might be not economical. If I make it to be maxed out on economics, it's not going to be efficient. So in this world called analog and mixed signal, it's a lot about trade-offs. All technology is about trade-offs. But what I can say is The amount of automotive OEM and tier ones that are reaching out to us asking for samples, I can tell you that the number is significant. I can't quantify it, but I'm not calling them saying, hey, you should use this. They're calling me saying, when can I get one? And that means when we do get it quantified, I think it'll be significant.
Last question from Arshu. Can you speak on manufacturing time, cost, and scalability versus competitors like NextGen? And is there any thought to licensing the manufacturing technology?
Yeah, we're working through right now, kind of freezing the process and getting all the cost accounting and economics figured out. We have a very efficient facility here, highly depreciated equipment. So we're expecting our manufacturing costs to be leadership because of that. Once I have the product kind of frozen and finalized, we'll be able to do that. But I feel very confident that cost will not be an issue for us. We've been very proactive with our suppliers as well to make sure that they're on board with helping us build a very high volume business. And from a licensing point of view, no, at this point, our goal is to, we're a product company. We want to build a product. We will be working with eventually an external foundry to go after kind of, super high voltage or super high volume business. And at that point in time, we're not going to license. Our intention is to retain ownership of everything.
Great. Mark, thank you so much for your time and presentation today. Do you have any closing remarks for our audience?
No, I just want to thank you, Anna. Thanks to Emerging Growth. Thanks to everybody who listened. Hopefully what you'll see is I like to be very present with the investment community in presenting things like this, one-on-ones, et cetera. So if you have interest, you want to learn more, by all means, reach out to myself or Jeff, and we'd love to help you understand more about Odyssey Semiconductor, ODII.
Perfect. Thank you so much, Mark. Hope to see you again in the future.
Thanks, Anna. Take care. Thanks, everybody. Bye-bye.
Okay, everyone, stay with us. We'll be right back with our next presenter.